Hello and welcome back, everyone, to COBOL Fridays. Today we have Irina, who comes with wealth of knowledge and expertise, working on the COBOL compiler team, focusing on IMS. So, who better to have with us than Irina to talk about the interaction of COBOL with IMS? So, without any further ado, Irina, take it away. And thank you,
Yes.
first of all, for being part of COBOL Fridays and being here and sharing your expertise with us.
Thank you so much. It's great to be here, and I'm happy to present about COBOL with IMS and share my experience. I guess let's get started. Today I will be talking about IMS programming structure within a COBOL program. We will also go over some components of IMS that you need for to do so. So let's take a look at the agenda. We'll discuss today what is IMS, look at a typical customer environment, which is actually very diverse. We are going to discuss a bit of what batch means versus online. We will look at some IMS components like IMS Database Manager, IMS Transaction Manager, and any related components. We will get into IMS application programming basics within a COBOL program and take a look at a sample program that will help you get started. So what is IMS? IMS stands for Information Management System. It has very high level of availability. It's secure, high performance, scalable. It's got two main components. One is IMS DB, which is a database manager, and what it does is accesses and stores data in a hierarchical type of database. So we will discuss what a hierarchical database means a bit later in the slides. A second main component is IMS TM, previously known as DC, and it's a subproduct that manages transactions, so it has an extensive transaction processing capabilities. It also has some services that enables the other to perform certain functions. If you take a look at the picture, what you can see is Transaction Manager, which can access IMS message queues. There is many different types of transactions coming into the Transaction Manager, and transactions, which are messages, including data, that could come from the web. It could come from terminals via SNA network. It could be coming via TCP/IP and much more. So Transaction Manager picks up messages coming in. Based on the transaction, it could put the data into IMS message queues, and there are many of those depending on your business need. There are so many defined, and based on transaction, it goes into the right queue. It also has a database manager, and that, like I said, takes care of accessing and storing data in IMS hierarchical databases. And of course, there are logs which are written in case something goes wrong in the system. You can take a look and see what actually happened. So let's move on. Let's take a look at a customer environment. First of all, there are many business sectors. There is banking, insurance, manufacturing, education, health, you name it. There is many different databases that we have, could be IMS databases, DB2 databases, and so on. Many different table structure sizes, sometimes all related to each other, sometimes independent. It's always multi-user. It's multi-transactional environments with heavy resource contention. And by multi-transactional, I mean millions of transactions going through each day. It has to be secure, reliable, perform appropriately, and has to have data integrity. There is a complex integration of IBM and non-IBM products, by IBM products. As you know, it could have IMS, it could have KICS, it could have DB2 running, it could have different programming languages like COBOL, PL1, assembler, C, and so on. Each application, each company has millions of lines of code, usually written. There are complex data layouts which are transformed between different business applications and sometimes within the same business application within programs. There is a usually complex integration of batch and online processing. So for those of you who are not familiar with batch versus online, let's take a look at what the difference is. Batch processing usually handles large amounts of data which are processed at certain time periods, and it can be stored and viewed at a later time. So when the system is not busy and results are not required right away, there is no user interaction, so the data is saved and then at a certain time it's processed. For example, something like reports. So in a banking environment, you could have account customer reports which go out, the statements are printed and sent to customers. Now that doesn't need to be done right away. The transactions are stored, they could be sorted, adjusted appropriately, and then printed and sent out. In terms of online processing, the requests are received randomly, they're processed right away, and there is output that goes out directly to the users. And by users, I mean it could be a customer at ATM, and it could be somebody, buying a product in a store and authorization is required. It could be a teller doing the account transaction on behalf of the customer. So there is interaction going on between the user and the system. So like I said, some of the examples are account deposits or credit card authorizations, which cannot wait till end of the day and they need to be processed right away. And just to mention, for online processing, you can have something like conversational versus pseudo-conversational processing. By conversational, you already know there is interaction with the user, but what happens is the program waits on the user to do something, right? So it sits and waits, it has the database logs, and it waits for the user to give it a response. Pseudo-conversational is a bit different. So it looks exactly like conversational processing, but what happens is it saves the state of the information, and the transaction completes until a user action happens. And a user action could be the user enters some data, hits enter, or there is a, for example, a help key that gets pressed, and then it goes back into IMS Transaction Manager. It says, I have a transaction starting up. The program comes up. It checks the state of the previous iteration, and it says, well, I have a response. Let's check it. Let's respond to the user again. So that really helps because it doesn't lock up database records in case it needs to update it. So that's very important given its multi-user, multi-transactional environment. So let's move on. Let's take a deeper look at the IMS components. First of all, everybody knows what a database is. Now, IMS database is a little bit different. It's a hierarchical database and data is stored at different levels. So if you take a look at the example below, we have a patient database. So patient is called a root. It does not have any levels above it. It's level 1. It doesn't have what you call a parent above it. So like I said, it's hierarchical and it's the main level of the database. So a person comes into a hospital and you can have patients, say we have 10 patients, patient 1 to 10 in a database. It could have information like emergency contacts, and that's the data of the patient segment, which is really a record for the database. Now, if you look at level 2, you have illness, billing, and household. Those are called children of the patient, and the patient is their parent. And there is a direct relationship. So, for example, say we have patient 1, and it could have a couple of illnesses. So illness 1 could be, there is high blood pressure, patient comes in with high blood pressure. Let's see, illness 2 could be somebody comes in with flu symptoms, okay? And for each illness, you could have several different treatments, which is level 3. So there is a direct dependency of the treatment on its parent, which is illness. So treatments, for example, for blood pressure could be, they're given IVs, they're sent home, and once the blood pressure comes down, treatment 2 could be certain medication is provided, and so on. So, and same goes for billing and payment. Billing is a child of the patient, and a patient comes in, a billing record goes out, and so on. Now, IMS database is responsible for storing and accessing data in this IMS hierarchical database. And then there is components like DBD. DBD is a database description. So it really looks at the structure of the database, all the fields, all the relationships. For example, it will mention every record in this database. So patient, illness, billing, household, treatment, payment. It says the whole database. And it will say what is the structure. So it will say illnesses, parent is patient, billing, parent is patient, and so on. It will have some other information. And then there is database PCB. Database PCB is a database program communication block. And for those of you who know DB2, DB2 has a view into a database, into a table. Now, DB-PCB is a view into a database. So if you have a program that only a doctor can take a look, so for example, you have patients, illnesses, treatments, that program doesn't necessarily need to see billing and payment, and that program doesn't care about billing and payment. All it cares about is patient, illness, and treatment. So the view into the database for a particular DB-PCB could be just that. So just to continue on the subject, next, there is a component of IMS that's called PSB. It's a program specification block, and it says all the PCBs of your program that your program will be using. So it will have all the database PCBs that will see the view into the data, every database that your program will touch. It will have the sensitivity level for each database. So, for example, your program can only access the information but cannot update it. That will be indicated by your PCB as well. In a transactional environment, it could have other type of PCBs for communicating for messages with the IMS transaction manager. So it will see messages coming in from terminals that IMS transaction manager will pass to you. Next, there are transactions. All the transactions need to be defined to the IMS system. And a transaction is a set of online input data that triggers the execution of a specific business application, top-level application program. And those need to be defined to IMS. And just to mention, all those components, they're similar to IMS assembler macros. So they need to be assembled, what is called gent, and defined to the IMS system. Now, for IMS Transaction Manager, what it does, it processes input messages received from a variety of sources. Like I said, data could be coming from the web. It could be coming through SNA network, TCP/IP, and so on. It provides a queuing mechanism for handling all IMS messages. So based on your definition in IMS, it will say, well, I have a transaction coming in, it has a certain data, I will put it into this message queue for which a particular program is associated with. So when the message comes in, the program will get started. It says, I have a message for me, give me my message, and it will do the appropriate business processing that you need. So it's high volume, high capacity transaction processing, handles millions of transactions a day, like I said. And let's take a look at the IMS application programming basics. For your program, first of all, you need an entry statement. Your entry is a DLI to CBL entry point. And you can provide it with all the PCBs that your program will take a look at. So the PCBs will have the really an address into the database and what database you need to access. It's not always necessary to pass the PCBs on the entries. There are other ways of getting information for the database, but I'll leave it outside of the scope of this presentation. But I will mention it's AIB calls. It's a little bit different, but it's part of IMS, and you don't need to pass it on the entry. You can actually get the address in a certain program, and that helps instead of changing all the programs and passing it along from program to program, that if you have multiple programs in your business application. Okay, so let's take a look at the DLI call statement itself. For those of you who know DB2 and KICS, those need to be have a preprocessor or coprocessor to understand what KICS or DB2 is doing. IMS is different. IMS are direct calls. The DLI interface is link edited with your object source, and we will take a look at how that's done a bit later with an example. So the calls themselves are of this format: call CBL to DLI. It provides it a function, PCB address. So for example, if you have a database, it will provide PCB for the database that you need to get access to or store information in. It will have a data area. So for example, let's take a look. Function is get data, right? So there is lots of functions, and some could be get unique. So you want to get a unique segment from the database, you'll provide it a key. The function will be get unique. It could also be get hold unique or get next, and those put a hold on the database so that nobody else can touch it, because your intent is to update the segment. So let's say we are only doing get unique. The PCB will be a database that you passed on the entry, one of the databases. Data area is where the data will be retrieved into. If you're inserting data or updating data, that data will have the information that you want to insert, for example. And SSA is a segment search argument. What it does is it indicates to the system what segment you want to update. So for example, for the patient database, if you want to update something in a patient segment, you will say as the segment name for the patient. If you want to update a particular segment, you will provide it a key. And there are two types of SSAs. There is unqualified SSA and qualified SSA. Unqualified SSA is a sequential access type of segment. So, for example, if you're traversing a database, you could say, I want to get unique with an unqualified SSA. That means you do not provide a key. You want to get the first segment of a database, and get next will get you every next segment sequentially. So you have to have a call statement CBL to DLI for each segment data that you want to retrieve. Now, the same call applies to transactional processing as well. You will give it a function. So, for example, you want to get a segment message from the IMS transaction manager. The PCB will be, for example, a terminal PCB where that you are communicating to. The data area will contain the message after you retrieved it from the IMS message queue via IMS transaction manager, but there will not be an SSA because you're not looking at segments, you're simply working with messages. So let's see. So just to give you an overview for the picture, you have an application. The way you communicate to IMS, you have DLI interface, which is COBOL to DLI, and you can do that from COBOL assembler and so on. And you can have two different type of calls. You can communicate to IMS transaction manager and get messages from IMS message queues. So a transaction request comes in, a transaction goes into IMS message queue. Then the transaction manager gets that message, brings up the programs that you need, and your message gets processed. You also have a separate path for IMS databases. So every database request that you need to do, again, you do it through the IMS interface, COBOL to DLI. You process whatever your business needs to do, and it retrieves the data, gives it back to the application, and so on. So let's take a look at an actual sample. If you're a beginner, the best thing to do is to start with batch type of processing. So this program does a traversal of a database. I only have one database in here. Okay, that's provided on the entry. So if you take a look on the second half of the screen, you'll see entry DLI to CBL using database. The database, if you look at the definition, it has a database name, the segment level status, processing option, and so on. So the status, you always need to check the status of a retrieval of a database or a message. And there, as you start coding, you'll look those up and you learn what the status codes are like. If in this case, for example, if it's spaces, you're successful. If you reach the end of the database, you have a different status code that's returned. So you have to know your status codes, and sometimes you need to check it within the program. Okay, so let's take a look at the actual program. The first thing it does to traverse the database, and the data is already preloaded in the database, it does a get unique using unqualified SSA. By unqualified SSA, I mean there is no key that's provided. All it provides is a segment name, XDB, DBD, GN, RT. Gets the data. So you provided a PCB, like I said, get unique status codes, which is GU. It's got the IO area, so the data will be retrieved into the TST IO area, and you define that based on the data that you're getting back, the fields, and you give it an unqualified SSA for the segment that you need. So that will give you first segment of the database. So further on, it does retrieval get next. Get next is sequential access through the database. So it will do it in a loop until there are no more segments. So what I did is I said, I will continue looping and getting my segments until the status is not spaces. So for my case, I know the database works, so I continue until there is the status is not spaces, but in reality, you need to check until you have the end of database or non-space, and you got to act appropriately. So if it's the end of the database, you're done. If it's something other than spaces or end of database, which happens to be GB, a status code, then you have to either report an error and see what's going on in your program. So for get next, you'll see it's again COBOL to DLI. The function is get next. The PCB is the database that's being passed to the program. And the data will go into IO area using unqualified SSA. Okay. And at the end of the program, I'm going to display how many segments I've read, and I'm done. So what I suggest, if you are new to IMS, start out with batch processing. Once you get the hang of that, you can move on to something called BMP, batch message processing type of programming, which helps you work with many different large amounts of data, where you can, for example, save a state of where you processed, and then do a checkpoint and then restart at a particular point. And that's important in a business environment because, so for example, if you want to finish the job by a certain time, you don't want to, in case of a problem and an abandon, you don't want to restart from the beginning. So you want to save the state of your program, and then if there is a problem, you restart at the point where you already committed the checkpoint. So, for example, if there is 1,000 records that you processed already, you did a checkpoint, you saved the database entries. In case of an event, you can restart from that point on and continue. And once you're familiar with batch and batch BMPs, you can move on to online processing, something like MPPs, and work with messages. It's a bit more complicated, but it's once you get the hang of batch, you can move on to online. So for the samples that we had, let's take a look at definitions. Like I said, there is DBD, which is a database description. In this case, for an example, I gave you a simple DBD. It only has one segment. It's called XDBD GNRT. It does not have a parent because there is only one segment in a database. In our database, there is 11 bytes for each segment record. The key is 10 bytes, so bytes 1 to 10 is the key, and then the rest is just data, which happens to be only 1 byte that's left over. And the key is of type character, and the whole segment is character as well. So that would be your definition, which you then gen, and your IMS product can then access that information, and your program can use it. Now for PSB, as you can see, it has a view into each database. In our case, we only had one database. And processing option is A. A means all. That means you can get information, you can update it, you can insert it, and so on. It specifies the key, which is 10 bytes. List equal yes means the address of the database. The PCB is passed on the entry to the program. And now the segment that you can view into this database is XDBD GNRT, which happens to be the only segment for our database. And the parent is equal to 0 because there is no parent and we only have one segment. The PSB name is TSTGN000, which happens to be match our program name as well, as you can see here. So just to mention a few things, like I said, there is no preprocessor or coprocessor for IMS. You have to link, edit your COBOL, IMS interface together with your source object. This is how you do it right here. Okay. When you run it, if you don't have IMS, you execute a particular program in batch. Now for IMS, it's a bit different. You have to go through IMS interfaces. So in this case, to execute our batch program, we have to call a program called DFS RRC000, and you pass it certain parameters. Some of them are the program name, TSTGN000, and you give it a PSB name, which happens to be the same as the program name, in our case, TSTGN000. You also have to provide it some libraries. You have to let it know where your IMS components reside, so your PSB libraries, your DB2 library. You also have, we are traversing a database, so we have to give it the database, where the physical database resides, and that's where we're going to get the information from, the gets and the updates if you need to do so. And let's see. So just to leave you with a few things, like I said, start with batch, move on to BMPs and MPPs for online processing. There is different status codes for the database that come back. As you program with COBOL, with IMS, you'll learn what they are, and it will make sense. Also, you'll get familiar with different events that could happen. For example, sometimes resources are down, the database is stopped. It will give you certain events. You need to learn what they are, and then you can restart them so your program runs successfully. So there's different types. If you're doing online programming, there's different type of regions in IMS, and that really depends. The type of IMS region and the type of database that you use really depends on your business need. And before you design the application, you have to figure out what those are. If you're not familiar, you have to go to a technical person within your organization, and perhaps a DBA in your area or for the company that you can go to, and they can always suggest to you what is it you can use. So there's many different databases for hierarchical databases in IMS, and it all depends what you need. In our case, if you look at the DB2, the access is HDAM awesome. So HDAM stands for Hierarchical Database Access Method. So you have a direct access into the database. But there are many other databases. Some are sequential, some are indexed, some are partitioned. And you have to figure out which database you really need. Okay. And that's it for now. Are there any questions?
All right. So we don't have any questions so far, but there was a comment, and I think, Paul, thank you. I think you've already responded on the chat, but for the benefit of our viewers and those who watch the recording later, perhaps, Paul, do you want to read the comment and share your experience? I see you've shared it here on chat.
Yeah, so it turns out one of the developers mentioned that he's debugged many programs where a segment length was increased and caused an overlay of the area followed the IO area. And he mentioned we solved it by having a large 4K at the time area in which the data was retrieved. And then he mentioned then a move statement moved the retrieved data to the O1 segment definition. And someone that, like myself, that used IMS back in the 70s, I know the MPP regions would come and go. And one of the reasons for the many MPP regions was for isolation. So many times these overlays could result in the batch message region or the batch region or the message processing region to potentially abend. Now, I don't know if you have any comments on that, because I haven't looked recently if the batch message processing or the MPPs have isolation that don't permit the overlay, or even if COBOL now is handling it where it won't permit the overlay. I'm just uncertain.
I would say you really need to dig down and look at the real problem and then see what's going on, right? Sounds like they're already programming in IMS, and if they can pass the information to somebody, I could probably answer it looking at the more details, right?
Yeah, and it sounds like they did the person solved the problem. They were just saying it was possible in the past to create an overlay, to create a, you've got a certain length, and then that length is overwritten, or it's written further than the length. And, but they found a way to solve it. But I do know from many, many, many years ago, the reason for the individual message processing regions was so that there would be isolation from the application of impacting other applications with an overlay.
Right. That's what I saw, and I think that's what it is, right? So, yeah.
Yeah. So
So it wasn't really a question. It was more of just a person sharing information.
Oh, I see.
Yeah, they were sharing their experience. I do have a couple other questions, though, Irina. The first one from Rod. Could you comment on rent, reuse, wait for input, RENT, reuse, and wait for input?
So if you have a reentrable program, it's brought into memory, and you can reuse the data so the program stays in memory. And for example, especially for online processing, very often the rent option is used, and so you can keep processing your program, and the data will stay instead of getting reinitialized. For example, especially for main level programs that you keep in memory, right? So you can reuse, and the data can stay there, and it doesn't need to be reinitialized.
And I do believe the re-entry sometimes was a technique to be sure that new work can enter the program without the previous user of the program impacting the new user of the program.
Right.
Kind of a re-entry technique.
That's right. Yeah.
All right.
Yes.
One other.
Yeah.
Okay.
Actually, I do want to mention that IMS. I've used DB2 and IMS together many times. As that's one of the questions that came up before. And you can have DB2 and IMS databases within the same program, and that works very well as well, right? So depending on your business need, you don't always need a hierarchical database. You need a relational database, and you can use both within IMS successfully.
Awesome. Another question here, can you describe about field attributes in IMS? Vineet, do you want to add to the question? Okay, yeah.
Field attributes of a database?
Yeah, so, and then he said PROTMOD.
Sorry, say that again?
PROTMOD, prot mod.
Yeah, I'm not sure, but the fields are usually. Sorry, was that from a DBD perspective, PSP perspective, from a program perspective?
Yeah, so that's why I asked if you could clarify the question. Thank you, Vineet.
Yeah.
So he just clarified the question and said Screenfield attributes. Can you describe about Screenfield attributes in IMS?
Okay, Screenfield is something else, right? So if you're using MFS, which is a screen painter within the program, right? So it's really, you give it each field that a user would see on the screen, and you can have, for example, protection mode where the field cannot be touched. So you display it on the screen, but the user cannot overwrite it or enter data. So that's a little bit different. It's used with IMS, but it's a screen painter. And you have MFS source where you describe each field on the field, including your protection mode, or if you can enter it, and so on.
Yeah, and I might add to that. So the message format service is, there's these things called message input device, message output device,
right.
And and it's basically the 3270 protocol. And so, right. as you know, even when you use a TN3270 or 3270, there's protected fields and unprotected fields. And as she mentioned, if you go into a protected field and try to type, it won't let you. You can only type into unprotected fields. So when you're building the message input, message output screen, you can say, I want that field to be protected, which means no one can type into it. And so I was just going to go ahead and add that, because it's really IMS's way of formatting the 3270 rules for that screen.
Yeah, exactly that. So if you want to display the title, I mean, you don't want to overwrite over it. So you just you put that into your input or output going through, and it will get displayed, and you don't the user won't be able to write over that. But so if you have fields, for example, where you need to enter data like account information, and your name and your branch and so on, from a teller perspective, then the user can override those, and that information will go back to the program.
Excellent. Thank you. All right. So one other question. This is, I'm just going to read it as asked here, and we can always ask for clarifications. Thanks for your presentation, Irina. Based on your experience, do you see any difficulty in IMS integration that could be addressed by some software engineering research? I mean, improve programmers' activities.
Or in terms of if there is research to improve programmer activity? I mean, I would say if you know IMS, it works very well. Right, so I'm not sure. There is always opportunities to do some sort of research and products to improve something, right? But as is, it does work very well. Did I answer that question?
Fernando, was that the? Yeah.
I can go ahead and add to that too. I'll interpret the question a little bit. But the IMS group, the IMS organization, definitely is advancing IMS and making it easier. They're making administration easier with Java tooling. And the other thing they've done recently, which would really surprise me, but I haven't used it, you can actually use SQL to get to an IMS DB. And I was shocked by it. I said, oh my gosh. And I thought that's rather fabulous, but I haven't looked into how or anything else.
I think that came with IMS version 13, and they have special SQL to DLI calls where you pretend it looks like DB2, but you're really accessing IMS databases, right? It's
so
pretty
to me,
cool.
That was a major enhancement, because if you struggle with the COBOL to DLI and all that, but you're comfortable with SQL, which many students are. I just thought that was fabulous what they did. It's kind of remarkable they're able to make that work.
Yeah, absolutely. Yeah. And they do have, I just wanted to mention, they do have different versions all the time. So there is something new every time, something that people can use, and lots of research goes into that. So, yeah.
All right. I don't think we have any other questions, Irina.
Yeah,
Just give
great.
us another moment, perhaps, if there's any other questions for Irina here today. And thank you, Paul, for kicking off our session with some really cool facts about IMS. And I see one of our viewers just added to it as well and said one bank in Brazil, IMS processes over 10,000 transactions per second over a single TCP/IP connection and APPC that is using IMS Plex share. So very cool.
Cool facts. Yeah.
Yeah. Thank you for sharing, Paulo. All right. I don't see any other questions coming in, Irina. Thank you so much for spending your morning with us and sharing your expertise around IMS and how can you actually integrate that into your COBOL program. Um, I would like to once again point out that all of these webinars are recorded and the recordings are available on our IBM Developer COBOL page as a video series. I've shared the link here in chat, and we look forward to seeing you again on the Friday, September 4th, for yet another COBOL Friday. Until then, stay safe and bye.
Thank you.